Harish.
Yes, sir, I have started.
Okay. Uh,
Shall I start, sir?
yeah, I think you can start, Pavitra.
Okay.
So,
So
Samantha
good
sir,
af
are you there, sir?
Yeah, I'm here. Okay.
Yeah, yeah. Okay, Pavitra, you can start.
Okay, sir. Good afternoon to one and all. I'm Pavitra, Assistant Professor, Department of Civil Engineering, VKIT. Welcome you all to the third day of the webinar on Design and Construction of Steel Structure. I welcome Mr. A K Samanta, GM, Mechanical, INSDAG, and I also welcome Dr. C.S. Shashikumar, HOD, Department of Civil Engineering, VKIT, faculties of Civil Department, and all the participants for today's webinar. The speaker for today is Mr. A K Samanta. Sir, now I request Dr. C.S. Shashikumar to talk few words about the session.
Uh, I think now we have actually changed the topic. It was supposed to be delivered by Dr. Ghosh, but because of unavoidable circumstances, he is unable to accommodate now. The session will be delivered by A.K. Samantha sir. I think you already know about him, is about A.K. Samantha sir, who is one of the convener of this webinar. Uh, Now he is delivering a lecture on the life cost assessment. Many a times we feel the RCC structure gives more life compared to the steel structure. Now I think Sir is going to throw some light on it, on the aspects of durability and the cost part of it. On behalf of the Vivekananda Institute of Technology, I welcome once again A.K. Samantha sir to this webinar, and also I welcome all the participants. Hope you will enjoy this session also. Thank you.
I kindly request Samantha sir to take over the session.
Okay, thank you, madam. Now I am sharing the screen. I think it is visible, sir.
Yes, sir, it is.
Okay. It is sliding.
Yeah, it is sliding, sir.
Okay. Okay. Good afternoon to all. First, my apology is there because Mr. Ghosh, Mr. Abhijit Ghosh was to be just in this time to deliver the lecture on light gauge structure. However, due to some problem, it was unavoidable. So, and the last minute, I have got a request from him to make some changes so that session should be on, but he was not available for this session. So, as a coordinator, I feel sorry for that. But anyway, these things happen nowadays, though everything is online, but still people are from distant location and they are having their own business priority. So as a result, getting the expert people also very difficult in time. Somehow, on my request, he has agreed. But again, last minute, around 1 hour back, I have got the call from him that somehow to manage the situation for today. So that's why this lectures, this presentation, I would not tell lecture that because things are known to you, only I am refreshing your mind or reminding you some small points. So this should have been at the last session, but somehow the due to circumstance like that, I have to continue just now in place of Mr. Ghosh. So sorry for that, and let me start that life cycle cost analysis of the structure. Now, this life cycle cost analysis, everybody of us, I think, understand, but still it is very difficult to practice. Now, let me tell how, and to some extent, we are doing also that. Concept of life cycle cost analysis, it was developed during 60s in the developed country, normally American and European countries. They realized that the product should be evaluated in terms of impact over the environment as well as the society. So whenever any product we are thinking of, product are normally manufactured through industry, and for today's classes the relevance is either steel or concrete structure, as India does not have normally wood structure or stone structure nowadays. So we have only two types of material for the structural application, that is one concrete, another is steel. Now anyway in concrete steel also there, but anyway for the purpose of assessment that over the environment, that was the main need during 60s to conceptualize that life cycle cost should be analyzed. Every industrial product make adverse impact by polluting atmosphere. You know, whenever any product is or any structure is constructed, we are consuming some material. That material has been produced through industry, or it is taken from the nature, from the earth. So indirectly, as we are getting one facility for development or facility of our for our life standard to make it easy, indirectly we are making some impact of the in the environment, and we are impacting the balance. As a result, nowadays that global warming is very common phenomena for us. We are seeing that adverse atmosphere or adverse environment nowadays. All these have resulted uh, from the that impact on the earth or impact on the environment by us only due to industrialization. As a result, society pays heavily to make the environment clean and to recover from diseases caused by the pollution. Gradually, concept of life cycle cost has been developed. Initially, it was started with the evaluation of impact on the environment only, though it was started with that concept, but later on it has spread to the other types of cost. And during 70s, the concept was expanded to almost all type of major decision making. Now, the idea, once it is conceptualized that some assessment should be there, then standard is required. You know, in all engineering process, that the standards are there, and we refer that because expert people makes the standard. If we follow, then our assessment will be more correct. Okay, it cannot be absolutely correct because there are some deviation, some confusion, but once standard is developed by some expert other people start using it. As a result, they also contribute in revision of the result. Now today, so for life cycle cost analysis is there, the most important code is there, ISO 14040 series. Exactly, there are 4 codes, but the basic code is ISO. You know, this is the international standard 14040. The title of the standard is Life Cycle Cost Assessment. Now, life cycle cost assessment is a quantitative analysis of the environment accept of the product over all its life cycle stages. And LCA is a systematic tool that enables the analyst of the environmental load of the product throughout its entire life cycle and the potential impact of this load on the environment. Products in this, let us understand this terminology. Products mean any type of products and service, whatever we carry out for our need. So there may be the construction of structure or the structure service itself. When the structure is in function, that itself is another product. Then emission to the air, water, and land. Whenever we are doing any activity, some energy are consumed and some pollutants are going to the either air or water or land or any other resources. Even the earth is having the minerals or ores that we consume. So it makes the effect on our earth balance, and it creates some problem for our environmental balance. Environmental impacts in LCA context refer to the adverse impact on areas, and that should be safeguarded as the ecosystem, human health, and the natural resources have to be balanced. Nowadays, we know that around 100 years back or 120 years back, that fossil fuel have come up. It was discovered. It was used for our vehicles. But nowadays, we are going to e-vehicle or biofuel just because of the pollution, because it is creating pollution in the atmosphere, and that polluted air is creating our health problem. Now we know the fact, only we don't know how to assess its impact or how to calculate it. Even that life cycle cost analysis has not fully conceptualized or fully quantitative. It has not come. some aspects are still assessed in the quality form instead of quantitative term. Now, history of structural material, as we are more concerned about the about our structure. So, what is the history of structural material? We know that when the concept of engineering was not known to the human beings, but one engineering stream was existed, that was the civil engineering. Because the day humans started their constructing their house, maybe in the form of some wood, maybe under the some trees or plants or whatever it may be. So from that day itself, civil engineering has started. Where the name civil engineering was not there, maybe, but that is the oldest type of engineering. And after that, gradually, mechanical, electrical engineering has come up only after discovery of that electricity by Benjamin Franklin, I think some 18 something. That is the year. So it is around 200 to 300 years old, this technology. While civil engineering technology or structural engineering is the oldest branch of engineering. It existed when the concept of engineering was not there amongst the human beings. And so far we can locate in our history, wood was the first processed your structural material, because leaf trees were natural. We used to take shelter like the your birds under the trees and plants. But after some time, people have thought that they should have their home, that as per their choice. So they took the wood from the forest and they processed the wood and they started building their houses. That is the oldest concept. Even for crossing the river or small bits, these canals, etc., people used to swim. Then the problem we have faced, that no, swimming is not possible every time. So concept of bridge has come. That instead of swimming, if we construct the bridge, then it is easier to cross over that water bodies. So by that way, bridge and buildings concept have come up, and later on stages, gradually as the people gain knowledge and got the touch of science, so gradually they have started using their brain for calculated engineering purposes. Then in the around 500, 600 years back or 1,000 years back, we got another structural material in the form of stone. Then we discovered the system of how to combine the many stone to a single structure. But anyway, these are not exactly fully scientific. Then brick is another structural material which was from the earth only by just heating or by just igniting the earth. So brick has also started coming from the earth resources, that is the soil. Now first material we can think of, that is the cast iron, wrought iron, followed by steel. Yesterday I have shown you during fabrication that one bridge I could locate, that is the oldest bridge I could locate in Raichur, that is over Krishna River Railway Bridge. It was constructed in 1961. It was the cast iron bridge, and that bridge has lasted for more than 150 years. Now, gradually cast iron, we know it was a brittle material, so people thought how to make it more ductile, because ductile people thought that brittle material breaks easily during impact. So we have started to thinking of that, what is the most ductile material. So then we have used wrought iron as our structural material. Wrought iron means there is almost carbon percentage in nil. It is very ductile, very soft, but its load carrying capacity is too low. So that's why few bridges or buildings were constructed with wrought iron in India, but that was very big structure. We thought that so structure should not be bulky. So we need a material which should give the optimum strength, ductility, as well as the its self weight of the structure. That is how steel, what we refer to as the mild steel, where carbon percentage is less than 0.3. It was first produced in England in 1885 by Dorman and Long, one company. And after that, immediately after that, within 15 years, we got the mild steel production in India with the started of these two companies. One is Tata Steel Limited in 1907, And quite similarly, ISCO, Indian Iron and Steel Company, now part of Steel Authority of India Limited during that time. So both the organization have started producing mild steel. As a result, mild steel was produced in India, and gradually after 1910, whatever structure were constructed in India, mostly by using the mild steel in India. Then concrete came during the Second World War, because in Second World War, people were making the defense equipment mostly of the steel. So steel was in demand, but as it requires a lot of processing and investment of huge money to produce the steel through blast furnace route, people thought alternatives should come. So that alternative concrete has started. Concrete means one manufactured material is there, that is the cement, and it was mixed with the your coarse aggregate, that is sand and chips, or the you call ballast, etc. So the concrete has formed. And again, after concrete, when it become into our life, then we thought that concrete is very strong in compression, but the structure is subjected to both compression and tension, and the torsion also, that is the bending. So now, to complement each other's properties, steel was inserted in the concrete. So whenever the structural members are subjected to compression, concrete will take the load. But in case structure is subjected to tension, then the rebar, that is reinforcement bar, that is steel bar, will take the load. With that concept, concrete was developed. We know in India, steel was under control, not available to general people till 1990s. As a result, concrete have become very popular, and not only that, in our education system also, gradually steel design got lesser important. So in many of the our structural engineers uh, recommended concrete structure instead of steel structure. However, still having some peculiar advantages, some places are there where really you cannot replace the steel. For example, rail for the train, not only the train body, we cannot think of any other material except steel. So, concrete is the very good structural material, but its application is limited, and steel is having unlimited application from medical science, from small things like pin, and big things like structure, bridges, long span bridges. When the span of the bridges is more than 100 meters, then steel become the only alternative. Now, anyway, that is the technical feasibility of using any material. But if the alternative is there, steel and concrete, what should we adopt? That is the main theme, main objective of this presentation, and how to carry out that. Let us come. Now, life cycle cost analysis is an evolution of technique of structure for management by which economy is decided based on the consideration of all associated costs. The cost may be direct, cost may be indirect, known may be unknown. We know the cost is there, but cost cannot be quantified. That's why known and unknown cost many are there. Suppose today my vehicle is emitting carbon dioxide or carbon monoxide to the atmosphere, but exactly the person who gets disease from that emission, it is not known to me, but certainly it has impacted someone's life. So the cost may be known or unknown. The cost may be created by me, cost may be created by others for which I am paying. Then present and future, all the cost will be involved in that. So we have to estimate all the cost, then we have to sum up all the cost, then only we can get the exactly life cycle cost of any structure. The annual operation and what is the need? From our experience, we have seen that if structure is constructed by suppose from 1,000 rupees, then exactly as long as structure is in there in its life, it is functioning, around 50% of its construction cost, 58% or 60% or 50% is its maintenance cost. So maintenance cost we also cannot ignore, because that also impacted our life. Whenever we have one product, its maintenance is also very considerable cost. For example, nowadays, if we are purchasing a bike, we not only that purchasing price, its maintenance price is also another cost. That's why after 15 years, when the vehicle become non-maintainable, we discard that. But during its lifetime, it also cost, maintenance cost is also quite significant. That's why they are telling that even maintenance cost to be incurred in future, so that will also be considered. Exactly, for with the concrete, this is what advantage, that concrete is does not need normally maintenance. Normally does not need maintenance, only some observation. But the negative point of the concrete is, once it produces crack, then it becomes non-maintainable. So there is some difference between the non-maintainability or no maintenance required. That concept need to be clarified by the structural engineers. Now, justification of the life cycle cost, as I have told you, that during construction cost, it may be 100 that if I compare the other cost, that one is your architectural cost for structure, another is construction cost, another is operating cost or maintenance cost. These are all direct costs have been depicted in this graph, but other costs are also there. Now, as I have told, what is the codes and standard? The most important code is ISO 14040. All are international standard. The title of this code is life cycle assessment principle and framework. In the extension of this code, there are another three codes. 14041 life cycle cost analysis, goal and scope definition and inventory analysis. Then 14042 life cycle impact assessment, impact on the environment. And then 3, that life cycle interpretation. So till today, these 4 codes are the basis of any life cycle cost assessment. Though all the codes are under regular revision, because the quantification of the sum cost, it is taking some time based on the data. So as those data are available, we are changing the code and we are changing the pattern of our calculation. Now other codes are there. One code in American code, you can see E917, that is the STM standard practice for measuring life cycle cost of building and building system. So it does not refer to the bridge, it is talking about the building. Another is A930, is their standard practice for life cycle cost analysis of corrugated metal pipe used for culvert, storm sewers. So this is exactly, may not be so much of relevant, but this code will give a lot of idea how to calculate a different indirect cost. And our Indian Bureau of Indian Standard has published two standard, 13174, that life cycle costing. It has two parts, and parts 2 is very important, that is being revised, and INSDAG is involved in that revision. So we are trying to best to develop our Indian standard. Now some terminology before this life cycle cost we need to understand. Base case. The base case is the alternative, usually having lowest initial cost is the alternative against which other alternatives are compared. For example, let me take, if I want to construct my building, then my first preference is the concrete, reinforcement concrete, rather it is reinforcement concrete. Now, if I think whether this reinforcement concrete building will be there or not steel building, even steel building having number of types, whether we will be used that beam angle channel or hollow sections or plate section. So based on this, there are so many alternatives. So base case is our concrete building, reinforcement concrete building, and others are the alternative. So alternatives will be assessed with respect to the base case, means the concrete building. Then base date. Base date is the date on which we are calculating the cost, because there are some future cost involved. We will not consider any past cost. The cost which have already incurred, we cannot revert that. But the future cost we can take care of, some control, that how to reduce the future cost. So base date may be any date, maybe before construction of the structure, maybe after construction of the structure. Any date, when the date on which we are calculating the cost, including the future cost and indirect cost. Then direct cost. What are the direct cost method? Nowadays, most all government or public structure are decided by the direct cost. The cost which are paid in rupees, that is the currency, in our currency, on account of anything related to the structure. Direct cost may be the cost of material of the structure, payment to contractor, payment to designer, and likewise, this can be present or future cost. So direct cost means the cost which actually in paper we can pay directly. Now here, who are we? We are means owner, the person who own the structure. For example, if it is bridge, the bridge will be constructed under railways, PWD or CPWD. If bridge is constructed under PWD, PWD think direct cost means whatever costs are paid by the PWD only. But you know some other costs are there, indirect costs, which are paid by the society and the people may not be paid by PWD directly. I'm coming into that scenario. Indirect costs, these are the costs that are paid but precisely may not be realized as being due to particular structure which are being evaluated. Cost of the overhead of the organization, additional staff for accounts, personal department, additional management required to run the organization are some of the indirect costs. So the cost which cannot be exactly categorized like particularly for this structure. So particularly for that structure, that is called indirect cost. But costs are anyway borne by the organization, maybe PWD, maybe we who own the structure. So these are called indirect cost, and indirect cost is always assessed in the percentage form of direct cost. That is always assessed. That's some percentage of total direct cost. Then known cost. These are the costs which are identified and quantified. So we know these costs. These are identified as well as the quantified. Please try to understand these two things, that we have identified it. If we cannot identify what is the cost, so that cannot be known cost, that will be unknown cost, and quantified. These may be direct or indirect. These costs are sometimes borne by the department responsible for design and construction, and sometimes are borne by the different department in different times, and maintenance cost is one such cost. You know, maintenance is carried out by the same department but not by the same people. So if today one department of the government is assigned to construct a bridge, he will consider that within coming 1 year or 2 years, how much cost will be paid by that organization. He may not consider the cost will be paid after 10 years during maintenance, what will be, yes. Because there is some limitation also. One limitation is that to calculate all those costs, it's a difficult proposition. Another thing, unnecessarily, we will be complicating our decision making. Direct cost method is the easiest way of calculating the structure's cost, because that is the initial cost. Future cost we are just ignoring. Unknown cost, these are such costs which are not paid at all by the authorities, but certainly paid by the society or country. Cost of rerouting the traffic. When bridge will be constructed on the road, so traffic will be rerouted. If traffic is rerouted, number of people will have to incur additional cost due to its vehicle or its fuel consumption, or due to some reason, or they have to travel more road. As a result, they have to waste the time. The time is also can be converted into cost. So these are called unknown cost, which PWD or government authority does not bother. Then another is pollution of atmosphere. During this traffic diversion, how much pollutant is being created in the atmosphere, nobody bothers. But impact is always with the society. Cost of rehabilitation of anything. Suppose one bridge has to be constructed on the road, but on the roadside there are some shops which have to be demolished, or some temples are there. So these may be authorized, these may be unauthorized. Sometimes rehabilitation will be there, sometimes rehabilitation will not be there. During the construction or maintenance or demolition of any structure, the owner generally ignore these costs during decision making, as it is not borne by the owner. It is very difficult to quantify also. It is, though undeniable and identifiable. We know there are some costs for rehabilitation of the people who are sitting on the road, but those costs are not paid by the department directly. So we cannot deny that, and the cost is identified. But as we are not paying, or the owner is not paying, he is ignoring that cost. But our country is paying that cost. Then another thing, when we'll be life expectancy, another terminology, when we'll be calculating the cost, as on today, we have to expect the structure will last for how many years. Now, during design time, we know there are two terminology. One is design life, another is surface life. Normally, design life of steel structure is 100 years. Nowadays, concrete is also constructed for 100 years. But maybe after operation of 10 years, 20 years, we can see the degradation of the structure or its inability to carry on the full load. So in that case, exactly, though it was designed for 100 years, but our life expectancy will be reduced. You know, structure cannot last for so many years. Maybe we have to demolish the structure or we have to re-strengthen the structure after 20 years, after 30 years. Many steel bridges, especially in railways, the steel bridges are re-strengthened because over the period of 30, 40 years of life, loading standard changes. As a result, steel bridges can be re-strengthened. But when the concrete bridges is constructed on the road by the authorities, if our load increases on the bridge, we cannot really re-strengthen the bridge. Then what we have to do, we have to put a placard that road is restricted for beyond this type of load. Sometimes truck, sometimes trailer are restricted, not allowed to pass over the bridge. So though the bridge is in existence, but still we cannot utilize it fully. Nowadays in our city area also you'll be finding that so many bridges, over bridges are there where load restriction are there. So load bridges are there, but it is not for all. So that means function is not fully utilized. So based on that, again, we have to recalculate the cost of the structure for the expected service life. Then another thing is discount rate. Discount rate is the rate at which the owner will devalue its money either paying or receiving at any point of time. Suppose here one concept is there. Suppose we are number of things for our individual is a number of things we purchase with the bank loan. So you know that with the bank loan, suppose one vehicle cost I want to purchase today, that cost is 50,000. But if I take the bank loan, so that will cost around maybe within 10 years after paying the full repayment of the loan, it will cost around 70,000. Now I have to calculate that what should be the best option. Should I pay the full amount initially from my pocket, or should I take it from the bank loan? So if bank loan over the period of time in the form of EMI and interest, we have to pay 20,000. Now we need to justify that whether this 20,000 we should give more or not. So the future 20,000 will be converted with some discount rate to today's value, because money will be devalued. So the interest may increase, may not increase. Sometimes it is increased, sometimes it is not increased. So that is the concept of discount rate, that future value will be discounted to today's value. In future any cost, if you convert to present day cost, the numerical, the quantity will be less. So that is called discount rate. This discount rate is used to calculate equivalent present value of the cost, which is paid at different point of time. There is exactly no system or guidelines to decide the discount rate. It differs from owner to owner, structures to structure, even decided by the party who is responsible for the evaluation. Even it is not clear how the discount rate take care of inflation, which are dependent on several other factors. However, effect of inflation on discount rate can be ignored. So if we don't know the exactly that inflation rate, we may ignore, because because as it is likely to affect all the alternatives in the similar manner. However, it should not be confused with the interest rate of borrowed finance or inflation rate of money, though it is decided considering both the rate. Now, in developed countries, some government agencies are there, America and England or European countries, their government authorities are there. As we are having that government authority under RBI or under Ministry of Finance about inflation rate, to calculate the inflation rate. So in other countries, that similar authorities are there, they publish the discount rate time to time. Then inflation. However, though I have told that inflation we may ignore because it affects all the other costs in a similar fashion. However, if we know the inflation, Then the formula given below gives the modified discount rate considering the factor inflation. Inflation will increase the cost at year end. Therefore, increase in the present day investment. The modified factor is known as net of inflation discount rate per year. Here it is per year given, that you can see the formula. That is the calculation formula for that discount rate. Then another things, residential value. Now let me suppose one steel structure, even if it is small structure, maybe 100 kg weight, maybe 200 kg weight. Suppose that has ended its service life. Now you leave the steel on the road, and in the next morning you will be finding someone has taken it, because the steel has some resale value. But in reverse, in otherwise, you see, if the concrete structure is demolished on the road, even nobody is willing to take that demolished material or debris. Even to discard or to clean the road, we need to pay. We need to pay for cleaning the road or to remove the debris from the road. That is the basic difference between concrete and steel. Steel is recyclable material, but concrete is not. Concrete is once finished its function, it is simply waste, only used for the earth filling or similar purposes. It cannot be used for any scientific purpose. Then present value, the cost of any account for the structure are paid during the different point of time, but the for evaluation purpose, the numerical value of the cost should be converted to equivalent present day cost. So if present day value is equal to A is the actual value paid after some time, 1 I think divided by 1 plus D whole to the power I think n is the number of years. So that is called that present value calculation formula. From a future cost, you convert it to the present cost. The life cycle cost, sum of all cost. If we have understood all the cost, sum of all cost, initial investment cost, present value of replacement cost, present value of maintenance cost, resale salvage cost, negative for calculation, that's exactly salvage value. As we are getting back, it should be negative in nature, etc. is known as the life cycle cost. So life cycle cost is the summation of all cost which we can quantify. Here you have to note that impact or on environment or impact on the society is not still there, because really till today we are not in a position to calculate all these costs directly, whether any pollution has taken place during this structure or these vehicles. Really we are not in a position to assess. I don't know when it will be possible, but people are trying, experts are surveying, they are trying to find out the cost determination way. Then methodology of analysis. Defining the requirement, the structure is considered to fulfill. First, we have to define that what is the necessity to having the structure in our society, maybe on the road, maybe on some places, but what is the necessity? So we have to define the structure first, functionality. Then determination of different type of specification or alternatives. Alternative may be by material, by designing, by constructional methodology, by maintenance procedure, etc. structure which will serve the same purpose for which the structure has been conceptualized. So first we need to define the need of the structure or specification of the structure, and then we have to think over the other type of structure which can fulfill our same requirement. Then establish common assumption such as study period, discount rate, etc. For all the alternatives, common assumption that is inflation or discount rate, all the we have to establish, and which we cannot establish, we may ignore it for the time being. Then identification of all cost. Whatever cost we have identified, that we have to convert it into monetary term. So direct and indirect, known, unknown, let us first identify the cost. Then assigning the new numerical values to the cost of each alternative. If some of the cost cannot be identified, the same cost may be ignored for each of the alternatives. However, if the cost is not applicable for all the alternatives, assessment of the cost is desirable to get the actual evaluation. If necessary, imagination based on the experience past data can be applied with justification for the purpose. So what does it tell? That the cost is known or unknown. So once it is known, we have to give some numerical value to all costs. But we will be finding some cost really we cannot put the value to that cost. As example, I have told that pollution or carbon emission or water pollution or your that earth excavation or the consumption of iron ores or consumptions of soils or your defertilization of the agricultural land. So all these things are there. So where we know these are the costs, but those costs cannot be estimated at the instance. So in that case, it is suggested by the expert that if any cost cannot be quantified, that may be ignored for the time being. But if we want to our calculation more accurate or as accurate as possible, then maybe we have to determine the cost based of our past experience. If the data is not available readily, but we are having some experience on that field, so in that way also we can calculate the cost. Then discount the future cost to present value. So whatever the future cost, maintenance or rehabilitation or re-strengthening or demolition cost, whatever we assess, that has to be converted to the present value with the discount rate. Then evaluating all the alternatives separately, but the same time. All the alternatives we have to evaluate at the same time. It is not that today I have the structure which I want to be constructed today, I will calculate it, and the alternatives will be assessed after 5 years. That is not possible. We have to evaluate all the structure, all the alternative at the same time. Then consideration of non-quantifiable cost and benefits. You know that what does it mean? That we know the cost is there. That is the pollution of air, pollution of water, pollution of soils. We know these costs are there, but that is not quantifiable. Then what we have to do? If it is really coming dangerous for our society, we have to take care irrespective of its value or numerical value more precisely, but we have to take care. That's why, for example, to reduce the pollution, we are upgrading our vehicles to e-vehicles gradually so that it should become non-pollutant. So for that, really, we know the effect is severe, but really we are not in a position to assess numerically, but steps are taken. Consideration of uncertainty in input values. Consideration, so if we don't know once we have decided the input value, then input value will have three types of numerical data. One is optimistic, another is pessimistic, and another is your highly expected, highly expected. So out of which we have to take some average value, and that average value will be taken for all the costs. Then computation of supplementary measure relative economic performance. Now, relative economic performance means suppose structure is constructed, but it has some other values also. That also we may consider. Number of historical structure. For example, today, if we take the consideration of Taj Mahal, we know when Taj Mahal was built around 400 to 500 years back by Shah Jahan, nobody has considered what will be the tourist attraction value. It was constructed for some other purpose as memorial of her wife's death. But nowadays it is the tourist attraction. Now really you cannot assess that how many tourists are coming to Taj Mahal and how much they are contributing to our GDP. So these are some additional costs associated with all the structure. Sometimes we construct the structure, we have to incur the additional maintenance cost, and sometimes we may get some cost back in the form of some additional income. Then work for the structure, which is evaluated to incurring the lowest type cost. So based on our all assessment, whichever is the lower cost, we have to adopt that. Now here, kindly note that no standard specifies the foolproof method of evaluation. Though several study reports on life cycle cost are available nowadays from abroad, and in India also several life cycle cost analysis report you can get. But National Institute of Standard and Technology USA has done pioneering and diversified detailed works on this subject. They have published several publications and developed computer program to help the agency for implementing this concept. Even they have identified prediction of structure is a bottleneck for the implementation of the concept. Means during our life cycle cost of structure, they have thought that that service life of the structures is the biggest unpredictable factor. So design life and service life, as I have told, it is separate. So service life sometimes exceeds the design life and sometimes it falls short of design life. Then few software are available. Here I have mentioned Bridge LCC, LCC wire. Some are the software available for calculating all these. Nowadays, many new software have also come because I have prepared this presentation few years back. That time I have came across all these software. But nowadays, many other software are also available. But for the structural purpose, whatever we are doing, even if software is not, if it is not available, we can go by the theory using simple computer program like your Excel, etc. That also give us quite justifiable result. Then, fortunately, in our INSDAG, we have carried out some project with the title life cycle cost. I am not telling it is foolproof, but I can give you some idea about the how the cost is calculated and how we have got the result. You may disagree with my result, whatever I find, but you can also redo the exercise. First is one life cycle cost of urban building. We took one typical study of G plus 3 and G plus 8 plus B buildings for concrete and steel option applicable in the Delhi. That time, exactly, it was around 12 years or 15 years back, we carried out that study. That time, we have collected the data from Delhi. We have assumed that, as I have told, common assumption, that building will last for 30 years and 6% is the discount value. Then direct construction cost we have compared. It is like the RCC and steel for both the option. Here you can see we have considered foundation cost, structural frame, floor system, building envelope, flooring and finishing item. Now you may tell me that what is the correctness of this data, whatever I have written here. Let me tell you, you need not go by this data. What I would like to suggest, if you work for PWD, if you work for railway, if you work for CPWD, if you work for any municipality, for all the direct cost can be calculated based on their scheduled rate of cost. Every big department publishes their own cost for the materials and for the workmanship. So you can take the cost from that way. Here only I have given you the idea that what are the costs we should calculate. Here we have compared the direct cost, and you can see in all the direct cost method, steel has become costlier. And in fact, without calculation, any structural engineer can predict that conventional steel structure will be around 20 to 30% costlier than RCC structure. Conventional comparison, that is the thumb rule. And here also it is indicating the same thing. But when we are taking that initial cost and future cost we have added, out of this future cost, you will be finding on your regular maintenance cost, periodic maintenance cost, repair, and its value. These data we have taken from the expert who understand the subject, as these data really in authenticated form it is not available. So we have collected from the experts and we have averaged it and we have taken some optimum value. Then we have found that as steel structure will last for longer time and have some resale value and some it will give some open space if we as the column free area is more in the steel structure, then if we utilize the space, then we can get some additional rental. So by that way, steel will become little bit cheaper, around 10% cheaper we have got compared to the RCC. However, again, I am telling you, this is not conclusive report. You may disagree, but I think you should go by this type of study on your own. Then conclusion, in both the cases, steel options are cheaper than concrete, as we have shown. It is observed that indirect costs like traffic diversion, cost during construction, space utilization, impact on environment are not considered. Though we knew this cost, but really we did not get any data for those costs. And still today, it is the bottleneck for calculating the life cycle cost. The data is available in European market. Some European standards are there. We can but we cannot refer to that because European environment or impact of environment is better considering to Indian scenario. But in Indian scenario, we do not have that data as on today. So here in our study, we have ignored those data. And I am telling you that with confidence that if those data somehow can be assessed based of the experience, the steel structure will be more cheaper. Anyway, another is also there that we have carried out another study, the typical urban flyover. That LCC of steel flyover is lower than concrete discovered. This is the only result I have shown. I am not going into details. Everywhere, if we take the consideration of maintenance and utilization of the space, these two factors and time period of the construction, then steel will become cheaper. Otherwise, steel is always costlier on direct cost method. Then difficulty. Now, as I have told already, lack of appropriate, relevant, and reliable historical cost information and data is the major disincentive to the use of LCC. Exactly, LCC calculation, though we know it should be, but lack of data is the main bottleneck. Maintenance data has largely been connected for accounting purpose to satisfy the reconciliation of the budget. So those data actually basically accounting data may not be actual data. There is some deviation. So we have to take it average in the percentage of, suppose from in past 5 years we have incurred around your 10% of initial cost. Maybe in next 10 years it will be around 5% of initial cost. But over the over the life we have to average it out. That will be the best result. The data used for estimating the contractor by the contractor for tendering purpose have wide variation in output, and these are relatively insignificant when compared with the consistency of maintenance cost record. Furthermore, little information is provided on qualitative nature. So this is another point, as I have told yesterday, exactly we are lacking in quality concerns. When we do our construct our own private structure, then really we try to make it more quality concerns. But when public structure is concerned, sometimes we see that exactly that quality takes the second seat. It is not coming to the first seat. But if the structure is owned by the private people, then structure is really very beautiful. Even in your Bangalore, you will be finding so. Sir, I'm starting.
Yes, sir. You can proceed, sir.
Yeah. Even in your Bangalore, if you pass through the road, you will be finding beautiful that your private structure. But not when public structure is constructed. I don't know why these are so ugly. Only it is for your that functional purpose. Somehow it should serve our purpose. For example, I am giving you the best example. I think airport. Your Bangalore is having two airports. One is old military airport and another is now international airport. Nowadays, that airport is maintained by the private people, private organization. That's why you will finding so many good maintenance and very elegant structure and economical structure. But once it was under the airport authority, it was ugly structure. Somehow space was given, number of columns and decoration was not so good. That is, the attractiveness was not there. But nowadays you can spend around 1 hour, 2 hours easily just visiting the Bangalore airport. And this is the similar case throughout the world. Whenever structure is owned by the private people, quality becomes very important factor. Then implication of life cycle cost. In case of evolution, it is observed that life cycle cost of any structure is not accurate, but indicative only, as many consideration and imagination along with the estimated future cost are involved. So here we are telling that if we go for the life cycle cost analysis, it is not possible to be the accurate. It is only indicative. That is my point. So there is possibility that decision taken based on the LCC may be sometime wrong, though most of the time it will be it will be very useful and correct. Maybe in few cases it may go wrong if the structure is very structural cost is very low and as well as very competitive. Then it may be wrong. Otherwise, if it is big structure, you will get the better result. Now, alternative assessment method. This is called uniform and annual cost method. I am telling this is another type of life cycle cost analysis. In first principle, as IS 14040 is telling that all the cost will be converted to the day of the calculation. Now it is they are telling no, as all the costs are not incurred at the first point or at the during the construction, better we have to distribute the cost over the period of the time. Something like if we take the loan today, so we should not consider the loan will be that loan will be paid today itself. So we think for coming 5 years, 10 years, whatever we'll be paying in every month or in every year. So that is the cause. If structure lasts for 100 years, why should we sum all the cost today itself? Let us distribute the cost throughout the life per year basis. So in that case, maybe today we have to spend less, but in future we will spend more. That is also another concept. That is called alternate that an uniform annual cost method. Here the formula is given. One example is given that alternative A has initial cost of 20,000 rupees. A life is expected 20 years. Annual operating cost 2,000 and a resale value is 2,000. Another B is there. That initial cost is 21,000, so little bit higher than comparative to alternative one. Then estimated for again 20 years. Annual operating cost is little low, 1800. Resale value is little more, 2500. And our in both the case interest, it is actually it will be constructed by borrowed amount. So rate of interest is 9%. Now, if it is annualized method, what should be the cost? That has been calculated. This is for alternative A. As per the formula, that factor has come 0.1095, and that uniform initial cost is exactly 20,000. If today we do not pay for the 20 years life, it will be 2191 every year. Then annual operating cost is 2,000, that is the fixed. Resale value is your again resale value, it is after 20 years, so we have to convert it over the year every year, so it is now rupees 39. So uniform annual cost, if we distribute the whole cost over the period of the 20 years, then it will be rupees 4152. In similar fashion, if B is calculated, it will be very competitive. Uniform cost will be 4051. So the B is cheaper. So in that case, you can see though initial cost is little bit higher than the alternative A, but alternative B is the cheaper one if we distribute the whole cost over the 20 years. Exactly in these 20 years, we have constructed the structure with borrowed amount, and we have paid the loan over the 20 years. Now, hindrance for maintenance estimates, hindrance for implementation of these costs. If we know that life cycle cost analysis will be good, or it will give us the better result for assessment or evaluation of any structure, why are we not adopting? We are not adapting because in private life we are adopting it anyway, directly or indirectly. Sometimes we calculate, sometimes we do not calculate. But if the structure is private, certainly it is calculated, it is debated, and then decision has been made. But for public structure, it is the thumb rule that we should go for the initial cost or direct cost method, initial direct cost method. Why our public authorities are doing the same thing? One thing, inadequacy of the fund. As we are a developing country, we have always some fund problem. The problem of fund has been continuing for last many years, and expected to be continued for several forthcoming years also. So exactly, and we have to construct a number of structure for the public. So public authorities will face the crunch of fund over the period of time. As a result, never they can go for the calculation of the life cycle cost analysis, which will direct you to pay more at the initial time. So what they will decide, they will continue to decide like that. Whatever today we spend and what is cheaper, we have to go for that one. But maybe the country or the public authority has to pay more over the period of the time. Another is that authority, though who have to take the decision, natural resistant to change. Whenever any change comes, our people are normally psychology are prepared to resist any change. It may be proved that some of the decisions taken in the recent past are wrong. In addition to that, decision makers feel that this is very complex method of decision making, needing high knowledge and skill by the evaluator. Orthodox type of education and work culture and socio-economic scenario also resist implementing the idea. So any authority takes the decision to go for life cost analysis, immediately the superior will ask them, why have you not implemented 5 years back? Why are you going to implement today? So if you think it is good, we will implement after 5 years. This type of our normal resistance to change exists in our society, in our mind. Then desirability of the life cycle cost. Already I have described the structure should be evaluated based on the life cycle cost analysis. but some alternatives are also there. Person to person, authority to authority, depending on the fund availability, they have to think some alternative methods. That life cycle cost always cheaper, we need not adopt that. What is the other things? That is, one is net savings. Net savings means savings accrued by the candidate alternative compared to base alternative over the life cycle cost calculated and converted to present value. Suppose today we go for save little bit of money, but with that savings of money, maybe we'll invest it in some other place where we'll get more return. Then maybe net savings should be our criteria. So instead of, suppose we are having that 10,000 crores rupees. Now today, if I estimate a good structure will cost 700 crores, we may not go for that. Rather, we will go for two structure at 500 rupees crore each cost. So that is called the concept of net saving. Then another is net benefit, as I have told, that one purpose is to construct the structure for some functional requirement as it is specified already. But some structures can give some additional return in the form of maybe some extra space will give some extra business, or maybe some tourist will attract it, we can generate some money, or maybe we can rent that space, additional space, and we can earn some more money. Or if the space is available inside the building, some more space, then we may utilize it for some other purpose. So that is the concept of net benefits. Then savings to investment ratio, that today if I want to build a structure, we may we may not exactly, for example, I am giving you very good example. In India, everybody everybody does not own any buildings. Many people prefer that instead of constructing the building, we should go for renting the building, so that it will cost less in my lifetime. Many people are there. They don't want to own the building, though everybody aspire that yes, I should have one building. But really, building construction is costlier, and rather renting a building space is cheaper. So that's why it is another. Why should I invest in constructing the structure if I can get it on rent in a cheaper mode? Then another is payback. Another concept. Payback means whatever money we are spending today. So what is the payment I'm going to get back? It is very much applicable nowadays in our. So when we are purchasing a taxi we will give on rent to driver, or we will be earning some money with that. So whether taxi should be purchased with the borrowed amount or not. If I can earn the money more than the EMI of that bank, so certainly we should go for the bank loan and start our business. So that's why in all the businesses, normally it is started by the fund borrowed by someone, borrowed from another organization or bank or another authority, and our payback is better than whatever we pay to outside people. So that is the concept of payback. So though life cycle cost analysis is very much desirable, but some alternatives are also there. Case to case basis, we have to adopt these things. So what I would like to recommend, that creation of awareness of the benefit of LCC analysis, at least for public structure, it should be carried out. National codes to be made for evaluation. As I have told, 13174 is under revision. We are trying our best to contribute. Now let us see how quickly we can revise the code. Then at some point of time, authorities owners have to take strategic decision for construction of any structure based on the life cycle cost analysis only. So let us wait for that time when government or any public authorities will take that type of decision. A committee or society or institute can be formed who will study only life cycle cost on different projects. So another recommendation is there. Maybe some authority, maybe some organization will come up. Those who will carry out the life cycle cost analysis. Exactly, their job will be to quantify the qualitative cost, that is the pollutant cost or soil degradation cost, or the natural resources degradation cost. All these costs have to be calculated. Now with this, I come to the conclusion that life cycle cost analysis, though it is difficult, but it is certainly relevant in our life. With this, I conclude here.
Yeah, thank you very much, sir, for your thought-provoking lecture. Sir, I think you have discussed about the history, the versatility of the structure,
Yeah,
of the steel structure. Then you have discussed about the maintenance cost. You showed us how to do the methodology of the analysis. Then you showed us some comparative study of
yeah,
the life cycle cost analysis between a
yeah, yeah,
GPS3
yeah.
structure
Exactly.
and a
Means yeah.
GPS8 structure.
Okay, okay.
And you all from that study you showed us whichever is cheaper, whether
Yeah, that exactly. We
RCC.
initially carried out the cost.
Yes, sir.
RCC is always cheaper on direct cost method.
Yes,
Always.
sir. Yes, sir. Yes, sir. But life cycle cost assessment is very important in every structure. That is
Yeah,
what you have emphasized today.
yeah,
And sir, I have few queries.
yeah.
Will the life cycle assessment, life cycle increase if we go for encasement of steel structure with concrete?
Encasement
Yeah.
means you are talking about the composite structure or
Yes, sir. Yes, sir. Yes, sir. Composite.
composite is better option because it gives fire resistance also.
Yes, sir. Yes, sir.
Yeah, composite. When concrete is very useful for fire resistance. In fact, when we have discussed yesterday the fire resistance, I did not discuss in very much. Concrete encasement is one option for fire resistance. But if we want to encase the concrete, if we encase the steel member with the concrete, it is better option. Let's take the advantage of the strength of the concrete. So that then composite it is coming. So nowadays composite beam, composite column, composite floor, everything is composite. Concept has come. It is now in under implementation. So there we can take advantage of both.
Okay, sir. Okay, sir. And sir, one more question, sir. In the life cycle assessment you did, you showed us the comparative study.
Yeah.
Did you take the effect of this carbonation?
No, sir, no. That's why I have told now, all those costs really we did not get, we did not include. Only the even this data you may argue, you may disagree because we have got this data only from the expert, whatever they have suggested. But
Okay,
really,
okay.
we in India we do not have any authority who finally will tell yes, this is the correct data. This is
Okay.
one. But for calculation purpose, our railways, PWDs, CPWDs, and some development authorities, they have their own schedule rate of that material and workmanship. So whenever they calculate the project cost, they have owned their schedule rate. So based on that also, if design is available, we can there only we can calculate the direct cost at initial level. But maintenance cost, etc. Till today we are considering from the experienced people based on their experience. Railways is having some data. They are considering around 3% to 3.5% should be the maintenance cost compared to their initial cost. But in other no other authorities maintaining that maintenance data. Only railways have some data on that respect.
Okay, sir. So also, in that assessment, have you considered this fabrication uncertainties,
Yeah, yeah, yeah,
such
yeah,
things?
yeah,
Okay.
yeah. Whatever known data, all we have taken. Only unknown data we could not touch. And again, I am telling you, sir, those are only indicative. Many other data are not available nowadays.
Mhm.
But European countries, they have their own standard. As I have told, if you refer to ISO 140 to 43, there everything has been so systematic. I have gone through those codes. It is systematic. Any educated people or experienced people can calculate the life cycle cost. Even their impact on assessment, impact on the air pollution, etc., has also been quantified nowadays.
So unless we do not consider this environmental exposure factor, I mean, if we do not consider that, can we still conclude that steel will be the better, having a better life cycle?
No, 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 sir. What I am telling you, again, I am not concluding whether steel is better or concrete is better or
No,
composite is
no,
better.
in general, I am talking, sir. In
In
general.
general, again, I am telling you, sir, you go to any experienced person on direct cost basis, steel will be, for conventional design, steel will be 20 to 30% costlier, initial cost basis, including your design cost, fabrication cost, etc. Even you today know that in the morning, Mr. Joseph was telling that steel prices is just up and down, totally unpredictable. This is the same thing with concrete also. That is also very much unpredictable. And you know another aspect throughout in India, it is going on problematic, that is the sand mining. It is mostly illegal. So, but sands are anyway required for the concrete structure. So all these factors we have to take care. Now, how exactly you will calculate all these things? It depends on who will calculate, and it is up to his concept. So normally project team, they calculate, yes, we should consider these and the data, and the data which is not available, we cannot do anything. So as I have told, it's a new concept still in evaluation stage, in India, and even code is not fully published with full data. Our INSDAG is contributing. We are member of that code, so we are trying our best to introduce those data. Let us see when it comes out.
Okay, sir. So thank you, sir. Now I request Siddharaju, if there are any questions from participants, can you take it up?
Yes, sir. Sir, we have one question from participants. So compared to precast, how the steel structure has advantage in terms of LCC?
Yeah, pardon, repeat kindly. Tell me again.
Compared to precast, how the
Oh,
steel structures has advantage in terms of LCC?
Acha, he has used one terminology, the precasting. So
Hmm.
precasting, and yesterday we have discussed with pre-engineered building. So we have to compare the precast structure with pre-engineered building. If it is pre for both the concept we have to take. If it is site fabrication, then we have to take everything on site. Our comparison should be on similar nature. So again, I am telling you, concrete, exactly, though we are telling the concrete, but concrete is having some steel component also. And so prefabrication is concerned, prefabrication of steel is also there. Again, if you sum up all the cost, steel structure on as initial cost will be costlier. Whether it is prefabricated steel structure or prefabricated or precast concrete structure, it is direct cost method. Steel will be little cheaper. But the advantage of the steel is that load carrying capacity. In case of concrete, if it is 40 to 60, means self weight to load carrying capacity. For steel, it is just reverse. So there is the advantage. So better option is go for the composite if possible, so that here everything is balanced. We are taking advantage of both steel and concrete. Both are very important material in our life.
Okay, sir. So one more question. So how to account the benefits of recycling or reuse of steel structures based on the savings in natural
Yeah,
resources?
that is the big saving for steel, because
Okay.
concrete really you cannot reuse except earth filling, but
Okay.
steel is fully recyclable. You put even one the half kg rod, you just throw it on the road, within 1 hour it will vanish from the road because it has good recycle value. But for concrete, if you demolish the structure, then it is really headache. You have to pay money to clean that spot. You have to pay money. You cannot get any money for that, because that reusable option is very less for concrete debris.
Okay, sir. Thank you, sir.
Sir, I think it was a highly informative lecture, and it is now I think all the students and the consultants can take up this activity, and they
Yeah,
can, I think, start estimating, start collecting the data, and
yeah,
they can just estimate their own life cycle assessment methodology.
yes,
And I think it will be highly beneficial for everybody.
yeah.
On behalf of Vivekananda Institute of Technology, I would like to thank you, sir, for giving
Oh,
such a wonderful information for us.
okay, sir. Thank you, sir. So tomorrow again at
Yeah.
11.
Yes, sir.
Tomorrow, my
Yeah.
colleague will present. Okay,
Yes, sir.
okay,
Yes, sir.
okay. Thank you, sir.
Thank you so much, sir. I think we
Okay,
can conclude.
okay. Thank you.
Yes, sir. Thank you, sir.
Thank you, everyone. Thank you, Samantha, sir, for such an insightful session. And I thank all the participants for attending this webinar. Tomorrow we'll meet again at 11 o'clock. Thank you.
Okay, thank you.
Thank you.
Thank you, Pavitra.